If f of x is equal to x into sine 1 by x for x not equal to 0 and 0 for x is equal to 0, then limit of f of x as x tends to 0 is equal to, as usual we have four options. I will consider this limit as x tends to 0 of f of x, which will be limit as x tends to 0 of x into sine of 1 by x. We know that sine 1 by x is a value between plus 1 and minus 1. Therefore, limit of this function as x tends to 0 is x into a value between minus 1 and plus 1. Therefore, when you apply the limit, this is equal to 0 into a value between minus 1 and plus 1. That is, limit of this function is 0. So option B is the correct choice. Limit as x cube cot x divided by 1 minus cos x as x tends to 0. So let us evaluate this limit. I will consider this limit as x tends to 0 of x cube into cot x can be written as cos x divided by sin x, and in the denominator I have 1 minus cos x, and I will multiply this by 1 plus cos x, and I will divide this by 1 plus cos x. Therefore, required limit becomes limit as x tends to 0 x cube into cos x into 1 plus cos x divided by sin x into 1 minus cos square x, because I have 1 minus cos x into 1 plus cos x, which is in the form of a minus b into a plus b, which is equal to a square minus b square. That is, 1 minus cos x into 1 plus cos x is 1 minus cos square x. We know that 1 minus cos square x is sin square x. Therefore, limit as x tends to 0 of x cube by sin x into sin square x into cos x into 1 plus cos x. Now we can rewrite this as limit as x tends to 0 of x by sin x whole cube. That is, I have x cube here. Sin x into sin square x is sin cube x. So we are writing this x cube by sin cube x as x by sin x whole cube. I will separately apply the limit, that is limit as x tends to 0 of cos x into limit as x tends to 0 of 1 plus cos x. Now let us apply the limit. We know that limit as x tends to 0 of sin x by x is equal to 1. Therefore, limit as x tends to 0 of x by sin x is also 1, which is 1 cube here, and as x tends to 0 I have cos 0, which is nothing but 1, and here also I have 1 plus cos 0, which is 1 plus 1, which is 2. So answer is 1 into 1 into 2, which is equal to 2. So option C is the correct choice. Evaluate limit as x tends to 0 of x into e to the power of x minus 1 by 1 minus cos x. Let me mention few standard limits so that we can use the same here in solving the given problem. So limit as x tends to 0 of e to the power of x minus 1 by e to the power of x is equal to 1, and limit as x tends to 0 of sin x by x or x by sin x, both are same, which is equal to 1 here. I will consider the given limit, that is limit as x tends to 0 of x into e to the power of x minus 1 divided by, we have 1 minus cos x is equal to 2 sine square x by 2. This is a trigonometric standard formula. So 1 minus cos x is 2 sine square x by 2. I have sine of the angle here is x by 2. So I want this x to be x by 2, so that I can apply this formula limit as x tends to 0 of sin x by x is equal to 1. So let me manipulate this. I have x by 2 here into 2. I need the square of this, so that I will square this, and I have to multiply another 2 here because 2 square is 4, and I have e to the power of x minus 1 in the numerator as it is, and I was having only one x here, but I have squared this, so I have to divide by x. I will write that x here, and 1 2 I have here, and let me write sine square x by 2. Here I have 2 2s are 4 here, so that I am left with, I have limit as x tends to 0 here. Now I have limit as x tends to 0 of 2 into x by 2 by sin x by 2 whole square. I can write this x square by 2 by x by 2 whole square by sin square x by 2 as x by 2 by sin x by 2 whole square into e to the power of x minus 1 by x. When we apply the limit, I have 2 into 1 square into 1, which is 2, because limit as x tends to x by 2 by sin x by 2 is 1, and also I have this formula limit as x tends to 0 of e to the power of x minus 1 by e to the power of x equals 1. So answer is 2, which is in option D. Evaluate limit as x tends to 1 of 1 by modulus of 1 minus x. We know that limit as x tends to a of f of x exists if left hand limit is equal to right hand limit. That is, limit as x tends to a minus of f of x is equal to limit as x tends to a plus of f of x. Here a is 1. I will consider left hand limit, which is equal to limit as x tends to 1 minus of f of x. That is nothing but limit as x tends to 1 minus of 1 by modulus of 1 minus x. This can also be written as limit as h tends to 0 of 1 divided by modulus of 1 minus x is replaced by 1 minus h. When you apply the limit, that is when h is 0, this becomes 1 by 0, which is infinity. And let us see what is right hand limit. That is limit as x tends to 1 plus of f of x is equal to limit as x tends to 1 plus of 1 by modulus of 1 minus x, which is nothing but limit as h tends to 0 of 1 by modulus of 1 minus of 1 plus h. When you put h equals 0, that is when you apply the limit, we'll get 1 by 0 again, so which is infinity. So in both the cases, limit is approaching infinity, so option D is the correct choice. Evaluate limit at infinity, that is limit as n tends to infinity of n into 2n plus 1 whole square by n plus 2 into n square plus 3n minus 1. Let me consider this limit as n tends to infinity of n into, let me expand 2n plus 1 whole square, that is 4n square plus 1 plus 4n. I am applying the formula for a plus b whole square. In the denominator, let me multiply this. That is, let us take the product of these two terms. That is, n into n square is n cube plus 3n square minus n plus 2n square plus 6n minus 2. In the numerator also, we can multiply by n. So I have 4n cube plus 4n square plus n divided by, let me simplify the denominator so that I have n cube, 3n square plus 2n square is 5n square, and 6n minus n is 5n minus 2. Now let us take n cube common both in numerator and denominator, so that I have n cube into 4 plus 4 by n. When you take n cube common, we will get this 1 by n square whole divided by, when you take n cube common in the denominator, we will get 1 plus 5 by n plus 5 by n square minus 2 by n cube. So let us eliminate n cube. When n tends to infinity, we get 4 plus 0 plus 0, that is 1 by infinity is 0. So 4 by n is 0 and 1 by n, that is also 0, and here in the denominator I have 1 plus 0 plus 0 minus 0, which is equal to 4. When n tends to infinity, that is when we have the limits at infinity, we can solve the question like this, or there is an easy method where I can consider the coefficient of the highest power. That is, you can observe this term here. We have, after multiplying both this numerator and denominator, we have 4n cube plus 4n square plus n here, and n cube plus 5n square plus 5n minus 2 here. So coefficient of n cube is 4 and coefficient of n cube in the denominator is 1. Coefficient of n cube in the numerator is 4, so I am writing 4. Coefficient of n cube in the denominator is 1, so I have 4 by 1, which is equal to 4. So 4 is the answer. So that is the shortcut way for solving the questions of the limit at infinity. So option C is the right choice. Let us evaluate n tends to infinity of root n by root n plus root of n plus 1. Let us write this root n in the numerator as it is, that is limit as n tends to infinity of root n divided by root n plus, in root n plus 1, let me take n outside, so that I will get root n into root of 1 plus 1 by n. This is nothing but limit as n tends to infinity of root n divided by, I will take root n common in the denominator, so that I have root n into 1 plus root of 1 plus 1 by n. So you can eliminate root n now. When you apply the limit, you will get 1 divided by 1 plus square root of 1 plus 1 by infinity. 1 by infinity is 0, so that you will get 1 by 1 plus root of 1 plus 0, which is nothing but 1 plus 1, which is equal to 1 by 2. So option B is the correct choice. Evaluate limit as x tends to a of root of 3x minus a minus root of x plus a by x minus a. To solve such questions, that is, when you apply the limit directly, let us see what do you get. That is 3a minus a minus root of a plus a divided by a minus a, which is equal to root 2a minus root 2a divided by 0, which is nothing but 0 by 0 form. When you apply the limit, if the limit takes 0 by 0 or infinity by infinity form, we can apply an important rule called as L'Hopital's rule. L'Hopital's rule. The spelling is L-H-O-S-P-I-T-A-L-S. L'Hopital's rule. Let us see what is this L'Hopital's rule. Let me consider this with this example, that is limit as x tends to a of root of 3x minus a minus root of x plus a divided by x minus a. Let us differentiate both numerator and denominator separately. Let us not apply quotient rule here, but just differentiate square root of 3x minus a. We know that d by dx of root x is 1 by 2 root x. So d by dx of root of 3x minus a is 1 by 2 root of 3x minus a into derivative of 3x minus a is 3. Derivative of 3x is 3 and derivative of a is 0. Similarly, minus root of x plus a. When you differentiate root of x plus a, you will get 1 by 2 root of x plus a into derivative of x plus a is 1 whole divided by derivative of x is 1 and derivative of a is 0. So now if you apply this limit as x tends to a, we have limit as x tends to a. Let me apply the limit. I have 3 by 2 root of 3a minus a minus 1 by 2 root of a plus a divided by 1. So now we can simplify this. This is 3 by 2 root a, 3 by 2 root of 2a minus 1 by 2 root of 2a. So 2 root of 2 into root of 2a is LCM. So I have 3 minus 1. So 3 minus 1 is 2, 2 is eliminated, and we will get the answer as 1 by root of 2a, 1 by root of 2a, which is in option B here. If f of x is equal to x when x lies between 0 and 1 and 2 minus x when x lies between 1 and 2, then limit of f of x as x tends to 1 is option A 1, option B 2, option C 0 and option D does not exist. So we know that limit exists, this limit of f of x as x tends to a exists if left hand limit is equal to right hand limit. So let me consider both here, that is left hand limit is equal to limit as x tends to 1 minus of f of x, which is nothing but limit as x tends to 1 of x here, because for x less than 1 left hand limit means the value of the function left to 1 and right hand limit means value of the function right to 1. So that is less than 1. I have x here, so I will write x. When you apply the limit, you will get 1. Similarly, let us find right hand limit, which is equal to limit as x tends to 1 plus of f of x is equal to limit as x tends to 1 of when x is greater than 1, that is 1 is less than x, I have the function 2 minus x. The function is defined as 2 minus x for x greater than 1, and for x less than 1 it is defined as x. So when you apply the limit, we have 2 minus 1 which is equal to 1. So left hand limit is equal to right hand limit. So limit exists and the value of this is 1. So limit of f of x as x tends to 1 is 1. Evaluate limit as x tends to 1 of log x by x minus 1. When you apply the limit directly, you will get log 1 in the numerator, and in the denominator I have 1 minus 1. We know that log 1 is 0 and 1 minus 1 is 0. So we got 0 by 0 form, so that we can apply L'Hopital's rule. So L'Hopital's, according to L'Hopital's rule, now limit as x tends to 1 of log x by x minus 1 is equal to limit as x tends to 1 of derivative of log x is 1 by x. You will learn this d by dx of log x is equal to 1 by x. So derivative of log x is 1 by x and derivative of x minus 1 is 1. So as x tends to 1, we get 1 by 1 which is equal to 1. So option A is the right choice for the given question. If limit as x tends to 2 of x to the power of n minus 2 to the power of n by x minus 2 is equal to 80, where n is a positive integer, then what is the value of n is the question. We know that limit as x tends to a of x to the power of n minus a to the power of n by x minus a is equal to n a to the power of n minus 1. This is a standard result. Limit as x tends to a of x to the power of n minus a to the power of n by x minus a is n a to the power of n minus 1. Here it is given that it is 80. That is, we have limit as x tends to 2 of x to the power of n minus 2 to the power of n by x minus 2 is equal to n into 2 to the power of n minus 1, which is equal to 80. This is given. Now we can choose the right answer by inspection method. I have n into 2 to the power of n minus 1 is equal to 80. First I will take option A. That is, if you take n is equal to 3, we will get 3 into 2 into 3 minus 1. That is 3 into 2 to the power of 2. That is 4, which is 12, which is not equal to 80. So option A is not the correct answer. And let me go to option B. Then it is 5 into 2 to the power of 5 minus 1. That is 5 into 2 to the power of 4. 2 to the power of 4 is 16. So 5 into 16, which is equal to 80. That is given is when n equals 5, it is 80. So option B is the correct choice. So even you can check with option C. You will not get 80 for option C also. That is 2 into 2 to the power of 2 minus 1. That is 2 into 2, which is equal to 4, not equal to 80. So among the given option B is the correct answer.